Welcome to the Butier Ranch. My name is Pierre. I am the local on-site agronomist here. And right now we're over by the well station that we use for the ranch here. Behind me you can see our main well. This is where all the water gets pumped into our storage tanks. So the water comes up, gets pumped through there, and we treat it with nitric acid to bring the pH down to an optimal pH range for growing raspberries. We measure the pH after it's made it to the storage tanks, and then we alter the recipe, the dosing rate, to make sure that we're dosing at the right rate for the pH. Behind me here you can see some of our stock fertilizer tanks. In here we make a proprietary blend of different fertilizers. We take water samples from the plants, both the feed and drain, and use that to assess how much nutrients the plants are using. And then we alter our existing recipes based on that. Our recipes are based on a concentration in parts per million or milliequivalents for the actual nutrients that we're sending out to the plants. So this room is essentially the brains of the operation for the ranch. This is where the fertilizer decisions are made. It's where the rigs decide how much to dose. These big blue tanks that you can see to either side of me are the mixing tanks. This is where the water treated with nitric acid mixes with those fertilizer tanks that you saw outside. Down here you can see these, which are called venturis. These are what are used to inject the fertilizer from the stock tanks into the mixing tank. This is where we have our EC and pH sensors. The rig calculates the incoming EC, the incoming pH, and uses that to decide how much to dose. If you set your dosing point of 1.6 and it's coming in at 1.4, the rig will automatically compensate for that and add 0.2 to the EC. The rig's able to know what water is coming in and out and make compensations to your existing recipes based on that. So you can see inside the mixing tank here, you can see where the fertilizer gets injected in and mixes in with the acid and the water before it gets sent out to the field. This allows for a really even mix and a better blend heading out to the field. The Priva system also has its own flow meters installed, which allow us to see exactly how much water is being sent to each valve each day. Using that, we can also calculate the amount of water being sent to each one of the pots each day. The average EC and pH are also recorded. The Priva system keeps a log of this going back several weeks. An extremely important part of substrate growing is making sure that your irrigation is uniform throughout the field, that each plant gets the same amount of water and that you don't get large fluctuations. One of the things that we do to help accomplish this is to use what are called pressure compensating emitters. So these emitters, no matter how much pressure is in those lines, send out the same amount of water regardless within a range. So for example, these ones are 4 liter per hour pressure compensated emitters. So within a certain range of pressures, these will always put out 4 liters per hour through these 2 spaghettis here. We use these stakes to also help direct where the water is going. Instead of having some of it going on the ground, we make sure that all of it is going right to where we want in the pots. As I said earlier, one of the great benefits of growing in substrate is that we're able to see what water is going into the pots as well as what's coming out. And this here is what we call one of our leachate stations, and this is where we measure that. We have this bucket over here on my right where all the water for the feed goes into that every single day. And then we have this gutter over here to my left. This is where all the drain that comes out of the bottom of the pots goes down that gutter and gets collected in another bucket. Every morning we come in, we measure the EC, the pH, as well as the volume in each of these buckets. We use that to know how much water the plants are using, as well as to see if there's a big increase in uptake of nutrients or a decrease in the uptake of nutrients. Every few weeks we send this water off for analysis to see what nutrients are actually being used by the plants. Then we use that information to alter our recipes to make sure that we aren't over-fertigating or under-fertigating the plants. Here in the Watsonville area, it's pretty typical to have cloudy mornings, and in these cloudy mornings you don't need to irrigate as frequently as you would on sunny mornings. We have several sensors throughout the ranch here looking at sunlight, and based on the total solar radiation or sunlight that the plants are receiving, the rig can alter when irrigations are occurring. On really cloudy mornings, instead of irrigating every half hour, it can push it out to every hour or every 2 hours. On those really warm sunny days, it can increase the frequency that it's irrigating to accommodate for the increased transpiration of the plants. So what we're looking at here is called a grow scale. This is one of the implements that you can use with the previous system. You can see these pots sit on top of this elevated gutter here. This gutter has weigh scales underneath it where it weighs those pots every single irrigation, and it sees how much weight they gain every time you irrigate, as well as how much weight they lose between irrigations as they take that water up. This gutter also collects the drain, which it then drops down into this holding container here, and that is then measured to see how much total drain is sent out on a volume.
Any excess drain is then diverted to be treated by a bioreactor to remove any excess nitrates that may be present in the drain water.
My name is John Scarden. I'm the CEO and founder of Tailwater Systems. The system is fed, if you will, by these local tile drain sumps that are located on this particular property. These are probably very familiar to you. And what we do is we then pump the water. Once it accumulates in the sump, we pump the water into a supply tank over there that you can see, and the supply tank provides constant fresh water pressure for the bioreactor pumps and control system, which are inside this yellow container here. So once the water gets into this supply tank, we use a level switch. So when the level switch says the tank is full, it'll turn on our system automatically, and the pumps located in this container will then move the water through the container, combine it with a source of what we call labile carbon, or biologically available liquid carbon, and then that mixture is pumped out the back of the container over here to the two bioreactor tanks. So the water containing nitrate plus the carbon source then is metered into these two tanks at the bottom, and inside these two 3,000 gallon tanks are hundreds of thousands of small plastic parts we call biofilm carriers. So the bacteria, which does all the heavy lifting in our system, colonizes these plastic carriers, and then as the water moves through the carriers, it has a lot of interaction with the bacteria. And so the denitrified water exits out this drain, as you can see at the top of the container. It comes down via gravity through this elevated drain